All right, we are moving on with our work on solving quadratic equations, and I am going to go over a new method, a new trick for solving complete quadratic equations called completing the square. Okay, and we'll start with an introduction and then do a couple examples here. And I have to say, it's not really a trick. It's a fully legit mathematical method, and it's actually incredibly useful. So before we start, though, I want to give you a quick reminder about squaring binomials. And this first one, always remember that this is not equal to x squared plus 9, okay? But what we do need to do is x plus 3 times x plus 3, and we are going to get x squared plus 6x plus 9, okay? And then I also want to show this one down below. We have a 4x squared minus 5 times 2 is 10, and we have two of those, minus 20x plus 25. So just a quick reminder, we call this the foiling process or double distribution. Whatever method you use, make sure you can get some consistently correct answers there. Okay, we're squaring binomials. The next part of our introduction is what I want you to think about is what do you wish you had to complete the square? Okay, so what do you wish was in these blanks so you could get a nice perfect square? And then maybe you might want to refer back to a video we did on factoring and multiplying special cases. But look at this guy up here. We had the 3 over here and the 6x and the 9 over there, with the rule being that this 6 was the double of the 3 and this 9 was the square of the 3. So let's have this be a 5, right? Because we want this 10 to be 5 doubled. And then this is going to be a 25. Okay? Something similar down here for the next one. Let's have this be a 6. So it's basically a negative 6 that we're plugging in because of this subtraction sign. And that doubled will give us a negative 12. And that squared will give us a positive 36. Okay, this next one's a little bit harder. Okay, I have more blanks for you, and we have this 4 out front that makes things a little bit challenging. But if we want to develop a perfect square from here, that's going to be a 2x. Okay, because 2x squared is 4x squared. And then we need to think about what might go in these blanks right here. Okay, and we could try some different numbers. Maybe we could try a 4 first. 4 times 2 is 8, doubled is not 24. So 4 won't work. Let's try a 6. 6 times 2 is 12, doubled is 24. So 6 is going to work. And then we just need to square the 6 to get a 36. To convince you that 6 works, let's actually FOIL it out. First two terms are 2x squared, outer two terms are 12x, inner two terms are 12x, and the last terms are 36. So this does give us the 24 that we wanted, okay? So just want to refamiliarize you with some patterns and some efficiency tips for squaring binomials, okay? So let's go ahead and do a completing the square problem. And the best way, I think, to learn completing the square is to just go through a bunch of examples. I don't want to give you a bunch of steps to follow, but I do want you to consider the sort of what you wish you had to complete the square that we just did. And that will apply here as well. So here's how to do this. Let's add 51 to both sides. You might be wondering why, because in prior videos we did the zero factoring or the zero product property with factoring. But I want to show you. I leave a blank right there. Okay? And then I want you to think about, what do you wish that was? Well, let's look at the 14. We're going to chop it in half to get a 7 and double it to get a 40, or square it to get a 49. So take the 14, chop it in half to get a 7, square it to get a 49. So I wish it was a 49. Let's make it a 49. We have mathematical power to do that. Okay, we're allowed to do that as long as we do the same thing to both sides. So the reason this is called completing the square is because this that's highlighted in yellow is sort of an incomplete perfect square. And by adding on the 49, we completed the perfect square. We sort of filled in a gap almost, okay? And we made a perfect square. So look what we can do now. We can factor easily the left. That's the whole point of what we just did. We have a perfect square, and we can simplify the right. We can square root both sides, and we have x plus 7 equals plus or minus 10. Remember, there are two numbers that square to get 100, a positive 10 and a negative 10. And then we can set up what we call our double pathway. So x plus 7 equals 10. Subtract 7, x is 3. So that's one solution. Our another pathway is x plus 7 is negative 10. So subtract 7, and we get x is negative 17. So there are our two solutions. So x is 3 and x is negative 17. What I think is always cool about completing the square is that we started with a problem that didn't look factorable at all, okay? But we did some adjustments by adding that 49, shifting the 51 over, adding 49 to get a nice, clean, factorable expression. All right, next one, same deal. What we're going to do is we are going to add 7 to both sides. And we are going to leave a gap to complete the square. So now we have an x squared plus 2x with a gap equals 7. What do we wish was in that gap? Well, we're going to look at this 2, cut it in half and square it. So we get a 1, and then we're going to add a 1 to both sides. So x squared plus 2x plus 1 is a perfect square now. Okay, so we have x plus 1 quantity squared equals 8. Let's square root both sides. And we have x plus 1 equals the plus or minus square root of 8. Okay, so we can then just subtract 1 from both sides. And thinking about how we do, how we represent radical expressions, we can actually write that a little bit cleaner like that. Okay. We can also choose to simplify the 8 or the square root of 8 because that square root of 8 has a perfect square factor. So we can reduce this down to 8 is a 4 times 2, and 4 is a perfect square. So we can square root the 4 and pull it out front. So we get x equals negative 1 plus or minus the square root of 4 out front, and then the 2 stays behind. So that's an exact answer. You're also welcome to go to a calculator and get a decimal answer for that guy. All right, we have a last one here that looks definitely a little more complex. But what I can see first is I just want to divide through by 3. Let's get rid of those larger numbers. Let's get rid of that coefficient in front of the x squared. It's going to make our lives a lot easier. We're allowed to just divide both sides by 3. So x squared minus 10 equals 3x. And now I'm going to do a little rearranging so that we can get it in our completing the square format. So I am going to subtract 3x from both sides, and I'm going to also add 10 to both sides. So I have an x squared on the left minus 3x, and then leave a gap. So these 10s cancels, these 3x's cancel, equals 10 on the right. I hope you can see we're about to get a decimal, and that's okay. Decimals are numbers too. Let's be okay with that. We are going to chop this number in half and square it. Okay, so that is going to end up being a plus 1.5 squared is 2.25, and a plus 2.25 over on the right. So let's simplify a little bit. X minus 1.5 quantity squared equals 12.25. All right, just to be clear, this 1.5 came from this negative 3 chopped in half. Okay, let's square root both sides. Okay, so we have x minus 1.5 equals plus or minus 3.5. Okay, and then we can follow, let's actually follow our double pathway here. So one option is x minus 1.5 equals 3.5, and the other option is x minus 1.5 equals negative 3.5. Okay, we can add 1.5 to both sides on the left, and we have x equals 5 as one outcome. And we can add 1.5 to both sides on the right and get x equals negative 2 as one outcome as well. So we have two solutions. Those are our final answers. All right, that's a good place to stop.